In simplifying rational expression, this is similar on how you simplify fraction. For instance, we have 24 over 32. To simplify this fraction, we have to divide them by their GCF. So the GCF of 24 and 32 is 8. Let us divide the numerator by 8. You will get 3. And the denominator by 8, you will get 4. Therefore, the lowest term of this fraction is 3/4. But aside from that, aside from dividing them by their GCF, you may also simplify this fraction by factoring them and canceling out the common factor. For example, the factors of 24 are 3 and 8, and the factors of 32 are 4 and 8. Cancel what is common. So cancel 8. Now we only have 3/4. Whether you will divide them by their GCF or you will factor them and cancel their common factor, you will still get the same answer. Now let's have an example for rational expression. We have 9a raised to 4 over 12a raised to 2. Let us use their GCF, the GCF of 9 and 12, to divide them. So the GCF of 9 and 12 is 3. Let us divide each. 9a raised to 4 divided by 3, you will get 3a raised to 4. Then 12a squared divided by 3 will get 4a squared. Alright. Then for their variable, to simplify their variable, you just have to subtract their exponent. It will be 4 minus 2. So cancel the smaller exponent, then subtract it from a raised to 4. So 4 minus 2, you will have 2. Now the answer is 3a squared over 4. So the answer is 3a squared over 4. So this is the final answer. Same with how you simplify fraction, you may also use their factors. For example, let us factor 9. So the factors of 9 are 3 and 3. And for a raised to 4, it means we have 4 a's. For the denominator, the factors of 12 are 3 and 4. Then we have a raised to 2. It means we have 2 a's. After that, cancel their common factor. So we have 3 here. It means we can cancel the 3 in the denominator. Then, for the variable, we have 2 a's in the denominator. Therefore, we may also cancel 2 a's in the numerator. So cancel, cancel. Then, for your final answer, we only have 3 and 2 a's and 4 in the denominator. Therefore, it will be 3a squared over 4. Same with our answer in dividing them by their GCF. So it's up to you which method is easier for you since you will obtain the same answer. Another example, x raised to 4 y raised to 4 over x raised to 7 y squared. Since we do not have numerical coefficient here, we may just simplify the variables by subtracting their exponent. So for variable x, we have x raised to 4 and x raised to 7. It means it will be 7 minus 4. Cancel x raised to 4 since this one is smaller, and we will subtract it from x raised to 7. 7 minus 4, we only have 3. So we have 3 cubed in the denominator. Then for the variable y, we have y raised to 4 and y squared. Subtract 4 minus 2. Let us cancel y raised to 2 since it is smaller, and subtract it with y raised to 4. So 4 minus 2 will only have y squared. Therefore, the final answer here is y squared over x cubed. So y squared here, then x cubed here. Okay, another example. We have 27x raised to 5y squared z over 45x squared y cubed z raised to 5. So we have numerical coefficient 27 and 45. Think of their GCF. The GCF of 27 and 45 is 9. Therefore, we may divide this by 9. 27 divided by 9, you will have 3. Then 45 divided by 9 will have 5. Then after that, let us simplify their variables. Let's start with variable x. X raised to 5 over x squared. So we have to cancel x squared since this one is smaller. Then subtract it from x raised to 5. 5 minus 2 will have x cubed or x raised to 3. Then for variable y, we have y squared and y cubed. cancel y squared since this one is smaller and subtract it from y cubed. So 3 minus 2, you'll only have 1. Then for variable z, we have z and z raised to 5. Cancel z. So this z has an exponent of 1. Therefore, we will subtract 1 from 5. 5 minus 1 will give us 4. Therefore, we only have z raised to 4. Alright. So when we write that in our final answer in the numerator, we only have x cubed. Then for the denominator, we have y and then z raised to 4. The exponent of y, which is 1, we do not have to write that. So our final answer is 3x cubed over 5y z raised to 4. Example number 1, 5y minus 15 over 2y minus 6. First step, let's identify what factoring method can we apply to simplify this rational expression. So for the numerator, 5y minus 15, can we apply here common monomial factoring? Yes, so for the numerator, we will apply common monomial factoring. How about for the denominator, 2y minus 6? Can we apply common monomial factoring? Yes, so we can also apply here common monomial factoring. Next, for the second step, let's start factoring. So for the numerator, to apply common monomial factoring, we have to get their common factor. So what is the common factor between 5y and 15? Yes, so their common factor is 5. It means you can divide 5y by 5. You can also divide 15 by 5. Okay, so to get the remaining factor, we will be dividing the polynomial by the common monomial factor. So it will be 5y divided by 5y. Okay, and negative 15 divided by 5, you'll get negative 3. Next, for the denominator, let's get the common factor between 2y and 6. What is their common factor? Yes, so their common factor is 2. And to get the remaining factor, just divide the given polynomial by the common monomial factor. So 2y divided by 2, you'll get y. And negative 6 divided by 2, you'll get negative 3. Okay, now let us proceed to the third step. Cancel all the common factor. So let's see. Compare the numerator and the denominator. What is their common factor? So they are the same with y minus 3. We just have to cancel it out. And your final answer will be 5 over 2. This will be your answer. Next, example number 2. So we have 3x plus 6 over x squared minus 4. The first step is, let's identify what factoring method can we apply. For the numerator, 3x plus 6, can we apply the common monomial factoring? Yes! So we will be applying here the common monomial factoring. How about for the denominator, x squared minus 4? Can we apply common monomial factoring? No, because x squared and 4 have no common factor. How about the difference of two squares? Is this in the case of difference of two squares? Yes, so we can apply factoring for the difference of two squares. Now, let's proceed to the second step, wherein we may start factoring. For the numerator, let's apply the common monomial factoring. So, we have to get the common factor between 3x and 6. So, what is their common factor? It is 3. And now, to get the remaining factor, we just have to divide this polynomial by the common monomial factor. So, 3x divided by 3, you'll get x. And then, positive 6 divided by 3, you'll get positive 2.
And for the denominator, since this is difference of two squares, to get the factors, you just have to get the square root of each term. Square root of x squared and square root of 4. So for x squared, square root is x. And then for the square root of 4, it is 2. So for your answer, it will be like this. X and then 2. X and then 2. Then you will use different operation. Plus and minus sign. So that's how we solve difference of two squares. Now, let's proceed to the third step, which is canceling all the common factors. So observe, look at the numerator and the denominator. What do they have in common? So they are the same with x plus 2. So we have to cancel it out. Now, for your final answer, we'll just have 3 and then x minus 2. So this will be our answer. You do not have to copy the parentheses since we do not have other factor in the denominator. So it will just be x minus 2. Now, let's proceed to example number 3. A squared minus 25 over a cubed minus 125. So the first step again is to identify what factoring method we can apply to simplify this rational expression. For the numerator, a squared minus 25. So let's see, can we apply common monomial factoring here? No, kasi they have no common factor. How about the difference of two squares? Yes, so we can apply here the difference of two squares. How about the denominator? A cubed minus 25. Can we apply common monomial factoring here? No. How about difference of two squares? No, because a cube is not a perfect square. How about the perfect square trinomial? Of course not, because this is not a trinomial. What else? Sum and difference of two cubes. Can we apply it here? Yes. So, we will be applying here the sum and difference of two cubes. Now, let's proceed to the second step. We may now factor the numerator and the denominator. For the numerator, this is for difference of two squares. It means that our answer will have two binomials. We will be getting the terms from the square root of our given polynomial. Now, let's get the square root of a squared. So, what is the square root of that? A. How about the square root of the second term, which is 25? 5. So, we'll have a plus 5 and then a minus 5. That's how we solve difference of two squares. Now, for the denominator, since this is sum and difference of two cubes, we expect an answer with a binomial and a trinomial. Now, to get the binomial here, we just have to get the cube root of each term in the given polynomial. So, it will be cube root of a cube and cube root of 125. So, what is the cube root of a cube? It is equal to a. How about the cube root of 125? This is 5. So, we will just write here a and then 5. Then, the sign will be from the given polynomial. So, it will be a minus sign. And in the pattern of sum and difference of two cubes, if the binomial has a minus sign, automatically the trinomial here will have two positive signs. Now, to get the first term here, it will be coming from this term, a. We just have to square the first term of the binomial. So, this will be a squared. And then, for the last term, we just have to square the last term of the binomial. So, 5 squared, it will give you 25. And for the middle term, we just have to combine the two terms in the binomial. So, it will be 5 times a. 5 times a will be 5a. So, that will be the factor of our denominator. Now, let's proceed to the third step. What is the third step? Cancel all the common factors. Compare the numerator and the denominator. What is their common factor? So, they are the same with a minus 5. So, we have to cancel a minus 5. And we'll get now a plus 5 for the numerator, ito po iyon, over the denominator, which is a trinomial. So, a squared plus 5a plus 25. If you cannot factor this anymore, this will be our final answer. For the last example, example number 4, we have here 5x squared plus 20x over x squared plus 7x plus 12. Now, the first step again is to identify what factoring method can we apply here. For the numerator, 5x squared plus 20. What factoring method can we apply? Can we apply here common monomial factoring? Yes. So we can apply here common monomial factoring because they have common factor. How about x squared plus 7x plus 12? Since this is a trinomial, our choices are just common monomial factoring, perfect square trinomial, and the general trinomial. Can we apply here common monomial factoring? No, because they do not have common factor. How about the perfect square trinomial? Dapat pag perfect square trinomial, perfect square ang first term, perfect square din ang last term. Perfect square po ba ang first term? Yes. How about the last term? No. So we cannot apply here perfect square trinomial. How about general trinomial? So, yun na lang ang natitira nating choice. I-apply natin yung general trinomial. Now, let us proceed to the second step, wherein we may start factoring our rational expression. So for the numerator, we will apply common monomial factoring. So what is their common factor? 5x squared and 20x. 5 and 20, what is their common factor? Yes, it is 5. How about x squared and x? What is their common factor? It will be x. For variable, you just have to get the variable with lowest exponent, which is x raised to y. So we have here x. And now, let's get the remaining factor by dividing the polynomial by the common monomial factor. 5x squared divided by 5x will get x. Kasi cancelled yung 5 and then just subtract the exponent of the variable. Then for 20x, 20x divided by 5x. So 20 divided by 5 will give you positive 4. And x divided by x will just be 1. So wala na po iyon. Cancel. Now, let's proceed to the denominator. So how will we factor a general trinomial? We have to get first the factor of the last term. So what are the factors of the last term? We have 1 times 12. It can also be 2 times 6 and 3 times 4. To know what pair of factors will we use, that we just have to add them and the result or the sum must be the same with the middle term. Now, let's add. 1 plus 12 will give you 13. 2 plus 6 will give you 8. And 3 plus 4 will give you 7. Pag pinag-add natin. So, alin dyan ang kaparehas ng middle term? So, this will be 3 and 4. It means that will be the factors that we're going to use for our answer. So, it will be written this way. X for the factors of x squared. And we will use positive 3 and positive 4 for the factors of 12. So, this will be our factors for the denominator. Now, let's proceed to the third step. Wherein, we just have to cancel out the common factor. So, what is the common between the numerator and the denominator? They are the same with x plus 4. So, cancel. We'll have 5x over x plus 3. So, this will be our final answer.